Today we're doing a change of variable in indefinite integrals. And then, once you get this under control, we're going to transition to definite integrals. And Nina has a question. There was no video Friday. We just worked. Week better. So, one of the things that's come up repeatedly is trying to take the integral of things that would normally involve a product rule, a quotient rule, or a chain rule, which we all know there's no such thing in integrals. So how do we work around that? We use something called a UDU problem. This is a fairly algorithmic approach. You know what I mean by that, right? What's an algorithm? Yeah, a series of steps. So we're going to do this, 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 and this, and then once you get it done, lo and behold, you've solved the problem. It's like magic. So, you're going to have to choose wisely. It's a little bit of a guess and check to start these problems. And what's going to happen is you're going to choose poorly, you're going to realize you've made a mistake, and then you're going to have to do it again with the correct choice. Some of you will not be able to move on in a problem unless you're 100% sure you've made the right choice. Too bad that's not going to happen. So, let's get right into it. Here's our first problem. So if I gave you the antiderivative of the square root of x, you'd have no problems, correct? X to the 1/2, blah, 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 yada, 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 done. However, this is a function within a function. If we were taking derivatives, it would be wonderful because we could use the chain rule, but no chain rule in antiderivatives. So we do what's called a UDU problem, and here's where you need to make a choice. Part of that problem you need to designate as U. And you don't have to use U. You could use whatever letter you want. You could use a smiley face. I don't care, but a common approach is to use a UDU. Okay, we're going to do a U substitution. So here are your options. You could choose U to be 8. That would be a bad choice. You could choose U to be 8x. You could choose U to be 8x plus 5. You could choose U to be the whole darn thing. Some of those are good, some of those are really silly. Any guesses? Bill?
8x and plus 5.
Let's give it a shot. So like I said, you're going to have to make some choices. Philip has decided he wants to make U equal to 8x plus 5. We're going to continue through to this problem. If he's right, we'll give him a rip-roaring round of applause. And if he's wrong, we will throw something at him repeatedly until he runs out of here crying. Okay, so, excuse me, here comes the algorithm. You pick a value for U, 8x plus 5. And now, in this little sidebar, you take a derivative. The derivative of U is du, because the derivative of U is 1, but you're doing it with respect to U, so you get a du. The derivative of 8x plus 5 is what, Philip?
8.
Good. 8, however, we want to stick a dx on that. Okay? Because again, it's like implicit differentiation. You got to let people know what variable you're working with. Not difficult, right? There are a couple different ways to approach these problems. Now, I'll show you how I do it and how I've had the most success with it. I'll show you the other method too, but you might not like it. Solve for dx. Okay? And now, the easy part. We do some substitutions. I come over here to my original problem. I get rid of the 8x plus 5 and put in a u. What's dx equal to? Beautiful. So you're all fairly bright, so I believe you'll be able to follow me if I do this.
Yes.
Is that good? Okay. Any problems? Okay, we're almost done. Now the fun part. This is equal to 1/8 times the antiderivative of u to the 1/2 du, which means that this is equal to 1/8 times raised up by 2/3 times x to the 3/2 plus c. Indefinite integral, back to plus c. Sorry, I made a mistake. Not x. U. There we go. That was an important mistake.
You're practically multiplying the 1/8.
Oh yeah, I'm not done yet. 1/12 times the quantity, 8x plus 5, raised to the 3/2 power, plus c. There's my final answer. Okay. Your final answer should incorporate the variable that you started with. I started with x's, I end with x's. As promised, let's give it up for Philip. Question here in the front.
So if we chose like the wrong thing.
Oh, hold on. We'll do one where we choose the wrong thing, just to see what kind of dark path that takes you down. Any questions? You understand the basic premise, yes? So now it's just a matter of practicing and looking at different options.
Mr. Reedy, why doesn't it go back to 8x plus 5 like once you get the 1/12?
Because our original problem is in terms of x, therefore our final answer should also be in terms of x.
So you just substitute all.
Yeah, just substitute it back in. So once I took the antiderivative here, I just replaced the u from the original value of u. Good to go. Okay. Number 2. Ooh. Now, if you were feeling saucy, you could take 8x to the 5th minus 7 and multiply it by itself 9 times. Good luck. However, I would prefer to do it using a UDU problem. Nina,
Yeah.
what are my possible choices for you? I mean, let's ignore the ridiculous things like 8 or the whole thing. Okay,
8x to the 5th minus 7.
one possibility.
Can you do the answer? Can you do the derivative? No. 8x to the 5th.
Good,
8x.
good,
X.
good. That's kind of ridiculous, but how about x to the 4th? Yeah. Could you 8x to the 5th minus 7 to the 9th?
No.
No?
Well, are you talking about 7 to the 9th or the whole thing to the 9th?
Whole thing to the 9th.
Then
Yeah, actually. One helpful rule is that, well, I'll make a statement first, then I'll tell you the rule. Remember, when you take a derivative, it drops the degree of the polynomial by 1. So in a situation like this, where I've got a statement raised to the 5th and another one raised to the 4th, you usually want to pick the higher one. So that having been said, what would you like to use for u?
8x to the 5th minus 7.
Just that. Can't talk into using that 9th?
I mean, you can, but I don't like.
You don't want to use it?
We can do it.
Well, it's up to you. I'm just asking questions.
Trying to get the wrong answer?
I don't know, maybe. Maybe I'm just trying to get in your head and confuse you.
I don't want to do it.
So you think that's going to work?
I don't know, maybe.
Well, let's find out. What's the worst that could happen?
Or what we got-
Right, because look, if I go like this, stuff erases. So we'll take it for a test drive. Nina, what's the derivative of 8x to the 5th minus 7? 40x to the 4th. dx. Okay, so when we start getting into this, what's going to happen is, and this happens all the time, when you take derivatives, you'll stick plus c's on there. When you take antiderivatives, you'll do dx's and that kind of stuff. Don't do that. Derivatives have the dx's and the du's. Integrals have that. Solve for dx. Nina,
Yeah.
did we choose wisely?
Maybe not. Kind of ugly, but.
Question?
Okay. Why is that like a rule you have to add the dx? Or it's like where is that?
Yes.
You just have to
It's,
use-
remember when we did implicit differentiation and when you took a derivative with something with respect to a variable that wasn't the one you're talking about, you needed to put a y prime on there? It's a similar idea here. We're letting people know, I took the derivative of u with respect to u, I took the derivative of x with respect to x. Now, this next step, as you do this more and more, you won't have to do the following step, but I'm going to do it anyway so you can see how this happens. I know that this is u, so this becomes u to the 9th. We're good to go, yes? I don't have anything to get rid of that x to the 4th, so I'm just going to write x to the 4th. Now, normally, if you have a statement that's got u's and x's, you screwed something up. However, we haven't finished yet. dx is equal to this. Everybody with me? Am I happy? I will be in a second. Whoopsh, whoopsh. Now I'm ecstatic. 1/40th times the integral of u to the 9th du. Once the substitution is done and all the canceling is done, since I only have u's, I'm happy. If you do the substitution and the canceling and you're left with u's and x's, you chose poorly. All right, so this becomes 1/400th u to the 10th plus c.
Oh, yeah.
How did it become 1/400th?
40 times 10.
1/40th times 1/10 because raise the power by 1 multiplied by the reciprocal. New number is 10, reciprocal of 10 is 1/10.
Why do you do the antiderivative? Add 1 below. 10 times 40 is 400.
We okay so far? How could we make it more challenging? Huh? Oh, we'll do that later. Yeah, that's Wednesday. We do definite integrals. Today, just indefinite. Don't have to plug and jump in there. What's that? It would be more challenging. Let's try this then. Oh!
Oh, God, no.
Okay. Drew, possible choices for you.
5x to the 4th plus 6x.
Excellent. Keep going.
X to the 5th plus 3x squared plus 5 to the 3rd.
Excellent. Any others?
I mean, you could just do x to the 5th plus 3x squared plus 5.
Uh-huh.
The stupid ones.
Yeah, then we got silly ones, like the whole thing. What would be a bad choice here? I mean, other than the absurd ones, what would be a bad, kind of intelligent choice that somebody might make?
The whole thing. Only factoring it.
The whole bottom. I don't.
That would be bad, but we'll go with it.
Okay.
Okay? Good. I like it. Let me clarify. This will not work out very well. This is going to turn ugly quickly.
Wait, but will it work? Just be ugly?
No, it won't work. You'll see, and that's why I want to do this, is because I want to see you, I want to show you what happens when you choose a bad U. So, and Drew, I'm blaming you 100% for this. He has decided, whoops. He has decided he wants to do this as U. So du is equal to 3 times x to the 5th plus 3x squared plus 5 to the 2nd power times 5x to the 4th plus 6x. Yeah, good choice, Drew. Oh, sorry, dx. What plus? Oh, I had it, it disappeared.
It's 6, not 16.
Oh, wait a second. Oh, my board started acting. Oh, there it's back. Now I've got plus plus. What the heck? Okay. So 1 over that mess.
That's disgusting.
Now, if I do a U substitution, it's going to get even uglier. As I go back to the original problem, I know the denominator is U, and I know the top and the bottom will cancel because they both have a 5x to the 4th plus 6, but the problem is I've got this other mess in there that's going to leave me with x's and u's. So I'll show you what the substitution looks like very briefly, and then we're going to realize that's a big mistake and we're not going to do that anymore. I have nothing to substitute this for. Why do things keep disappearing? This bottom becomes u, and then dx is equal to this mess.
Do you have to put on that side? Can I just put on one side on there?
No, because you'll get it in the wrong level. So that cancels with that, and now all of a sudden I've got u's and x's which are bad. So Drew chose poorly. That's okay. I goaded him into doing that. We're going to erase and do it again. Drew, what would you really like to use for you?
5x to the 4th plus 6x. No?
Choose the higher powered one.
Oh, so just x to the 5th plus 3x squared.
There you go. X to the 5th plus 3x squared plus 5. Therefore, du is equal to 5x to the 4th plus 6x dx, which means that dx is equal to 1 over that mess du, which is good, because now when we substitute, again, I'm going to do the extra step here just so you can see where it comes from. The integral of 1 over u cubed du. Ooh, I'm happy. Only u's. Life is good. But we fixed it. And I'm going to assume that you could go on from there.
Wait, no.
I'm not going anywhere. I'm just saying I'm assuming you could if you wanted to. U to the negative 3, yada, yada, yada. By the way, what's negative 3 plus 1? Just checking. Good. So we started with a nice, easy concept. We made it more interesting by turning it into a rational function. What's next, kids? Trig. Drew, question.
Is there any good way to guess besides just whatever's the highest power?
Usually, about the only thing I can tell you is the highest power. And you'll notice why, even though x to the 5th plus 3x squared plus 5 is the highest power, you don't want to take the cubed with it.
Okay.
Because when you take the derivative, you also have the chain there, which causes problems.
Okay.
No!
Could you finish this one out? Like, what do we really do for the rest of this? Do we just bring the u to the 3rd up top, making it u to the negative?
That's what I would do.
And then you take the derivative of that?
And technically speaking, you'd rewrite that to get rid of the negative exponent, but at this point, I don't care about it. That'll come later.
So if that was on a quiz and we left it like that?
That like that?
Yeah.
It depends on the quiz. It depends on what the directions tell you. If it says simplify as much as possible, that would not be acceptable. If it doesn't say, that's fine. Eventually, we're going to get to a point where any type of problem with negative exponents will have to be simplified, no negative exponent. two rules. We'll be looking for no negative exponents, no fractions within fractions. Okay. Trig. Whoops. Throw it right on the ground. Andy, what's you? Nope. 12x. That'll work. Okay. This one's pretty straightforward. Whoops. Cosine of u du. What's the antiderivative of cosine? Sine. Sure it's not negative sine?
Yeah.
All right, just checking. Okay. You do that one on your own. Oh yeah, come on now. Get it. God has nothing to do with it.
I do 8x to the 4. Because sine 4 is the same as sin sine x4.
I'm earning a living for God's sake.
What times 8?
Make it
42, right? X to the negative, x to the
Tell me that we're going
dx. And then we would do 1 over x to the 5, right? Du equals dx. And then I feel like it needs to be 8x because it's cosine 8x.
I'm sorry.
Okay.
It has to be if you take out the sine.
It's a thing for sine. It's cosine. Negative cosine?
Sine 8x, cosine 8x. Right? That's cool. Cool. But how skinny is that for?
Okay, what's the derivative of sine?
Cosine, negative cosine, negative cosine.
Okay.
And then find the derivatives. Okay, this is what I thought. Stop yelling. Stop yelling.
Negative 1/8 cosine. Negative cosine 8x. Is 4.
This is u to the fourth.
And then sine 8x.
No, it's switch, yeah. You don't know how to take the antiderivative of that?
Cosine?
I don't.
Wait, is this right? Well, I think that's the same answer. I don't know. Is this right?
Nope. Why didn't you say that?
I got a 69 school pass.
Okay, so let's talk about these types of problems. One of the reasons I didn't tell you what to choose for you is because part of the challenge of UDU problems is being able to recognize when you've made bad choices. So a lot of you, in fact most of you, chose 8x to be u, correct? So when you do the u substitution, the only thing that changes into is sine to the fourth of u cosine of u. Well, you don't know how to take the integral of that. So what you need to recognize, and some of you cannot move on unless you have the right answer, is you just have like a total brain lockup because you know it's not right, but you're afraid to take a chance and try something different. So that doesn't work. Then what do? Well, you try something else. But none of you did, right? Well, I should say none of you. Megan is going ham on that problem over there. She chose u to be what now?
Still 8x.
Yeah, she tried 8x, which won't work, but she tried something different. She turned sine to the fourth into 1 minus cosine to the fourth. And she's doing a bunch of ugliness, right? And it's not getting anywhere. My point being, she's trying something. Instead of sitting there staring up in the bright lights because you're afraid to make a mistake. Get over it. So, instead of just telling you, other than 8x, what else can we try as u, babe?
8x to the fourth.
I don't know, would this work if you did sine to the fourth 8x?
Let's try it.
What?
So again, the point here is that I purposely didn't say if this is going to work or not, but what I would like you to be able to do is recognize when I get to a point when we realize this is going to work or it's not going to work. So your hypothesis is you want to do this, correct? Okay. So then we take the derivative. Whoops. I missed a minus sign in here, didn't I? Derivative of sine is negative cosine? No, derivative of sine is cosine. Yeah, so I'm good. Where'd my x go? No, it's not. That's it. So this is 1 over 32 sine 8x cosine 8x du equals dx.
Should it be sine 8x to the third?
Correct. Thank you very much. Glad you guys are here. I was just testing you.
Yep.
Good. Okay. Now the fun begins. Now I do my u substitution. I know that this first thing is u, so that becomes u. I have nothing to sub in for there, so I'm just going to write cosine 8x, and then I'm going to cheat because I'm lazy and take this monster and just slide it right over there like that. Slicker than whale dung in an ice floe. Oh, wait, we might be onto something, Faith. Look at that, cancels like that. That's good. Or is it? Say again? Right, so at this point I know we chose poorly because I have x's and u's.
Oh my gosh. That got crazy.
That got crazy quickly. All right, so again, we have an eraser, so we're going to use an eraser and start over. Last chance.
8x to the 4.
Say again?
8x to the 4.
Nope. Not the whole thing.
Cos 8x.
No. No.
What the?
Say what? I didn't hear you. I'm sorry. Nope.
Oh boy.
Sine 8x.
Maybe this will help.
Sine 8x.
Is that a bad color? Sorry.
Really bad.
If I rewrite the problem, I've changed nothing. I just rewrote the problem. Does that help you figure out what you should be?
Sine 8x to the 4.
We did sine 8x to the 4th
8x to
already.
the
Pay
4th.
attention. Sine 8x! Woohoo!
Oh, come on.
Shut up. God. Whoops. Oh yeah, come on now. Kaboom, kaboom. That was fun. Okay, how can we make it worse?
I literally don't know.
Sure you do.
Keep on going.
Or you.
Oh no, that's easy. No, I'm trying to do problem.
Oh, you 15 divided by 5. No.
How could that make it worse?
No, the next problem. This I'm done with this. I'm not going to finish that. You should be able to do that on your own.
Oh, okay. I was like, what are
How can I make the next problem work?
Oh my god.
A division.
Right, I could combine a rational function with trig functions and do
Absolute
that.
value.
So let's look. Oh wait, I don't have any more problems.
This is very easy.
The weird thing about this is that it only works for very limited problems. So anytime you're given a problem like this, it will get to the point where it almost seems contrived. Whereas when we did derivatives, we could take the derivative of virtually any function because we had product rule, quotient rule, chain rule, all that other fun stuff which allowed us to do all those different techniques. These U to U problems are fairly limited. So for instance, if I didn't have the cosine of 8x attached to that sine to the fourth of 8x, we wouldn't be able to do the problem because nothing would cancel. Okay? So again, some of you are going to have to take some chances and figure out what you're going to try for you and take it through to completion, realize you made a mistake, erase, and start over again. Or you won't. It's up to you. Okay, questions? Because 8x didn't cancel everything, or you got to a point where you had a function but you don't know how to take the antiderivative of it. Exit? No.